think we're live. Looks like we're live. Okay. So I'm going to just try something out here because a lot of people ask me about my process, how I go about doing things, and it's really hard to like get into the nuance of my process through like short form video or even the long form video because things have to move in a certain way. So what I'm trying to do here is I'm trying to run a little bit of some live design. I haven't done this in a very long time. So thank you everyone for joining. How's the audio right now? Can you hear me okay? Let me know. What's up? Damn, yes. Let's go. Okay, perfect. Audio, video is okay. Okay, so right here on my screen, you have SolidWorks. I also have another camera. Let's see if this is working. You can see this is where I do all my sketching. How does this look to you guys? It's looking good. All right, let's see what happens. So the plan for today is to design a latch, which will hopefully when you fill it up with marbles, it will unlatch, and then the thing that's holding the marbles will drop, and then that's going to like, I don't know, like drop, and then it's going to trigger some sort of action. This is kind of like a random idea for the moment, but it will start to make sense down the road. Basically, when I was designing this big Rube Goldberg contraption, it's almost like 2 or even 3 years ago, the plan was to have the whole Rube Goldberg machine triggered by little marbles. So there's a big marble, like something kind of like this size. Interesting. I guess the green screen's on. That's funny. And then this would be driven by, let's see if I have, rare that I don't have a marble sitting on my desk, but I can grab one. So it would be driven by a marble of this size. So a bunch of these small marbles will be like rolling through the track. They're going to dump into like a bin. And then when enough of them jump in, the weight of them all is going to cause the bin to drop. And then that's going to cause a bigger action. Okay. That being said, I don't know exactly how we're going to do this yet, but we're gonna work on this together, and you guys are gonna help me through the process, and you can see how I think through things, and potentially even use some tools to help us design and figure things out. So we'll see how it goes. So there's a couple goals here. One of the goals, I'm gonna write this down. Maybe we can keep this like on the screen here. So. Okay, let's do it this way. I think might be, I don't know. Guys, this is my first live stream, so bear with me. And we're going to figure something out. So the reason why I really like marbles is because it allows you to play with physics in like a really interesting way. And yeah, I think marbles just like they roll well. They like can, you can direct them and whatever. So yeah, I do like marble machines. And I love what we can do with the engineering of marble machines. I think it's just like kind of like endless, and the possibilities are just like huge. So let's write down our goals here. We're gonna go with this. We have this marker right here, and we're gonna switch to this camera so you can see where I'm writing. And it looks like our lighting kind of sucks, but it is what it is. Okay, so we are trying to make a weight, and excuse me if I misspell things. I've kind of jumped into live streaming now. I didn't really think about anything else, but okay, we're gonna make a weight powered or a weight activated latch, and the whole thing is going to be like mechanical. So there's going to be no electronics in this. So we're going to do the whole thing mechanical. And then we're going to say, I don't know, this is a terrible list of goals, but it is what it is. the latch is gonna, you know what? Let's just jump in. This is what we got here, okay, everyone? How do I add this? The Marble Clock series by Ivan is probably my favorite thing on YouTube right now. I love it so much. He's an absolute madman genius. He's one of my good friends in the creator space, and I love what he's doing. It's just so fun. Weight activated while being mechanical is going to be hard, but we do hard things on this channel. So yeah, it's going to be fun. How do we add text? There it is. Okay. Create new text. Boom. And we're going to do this. Goal. Create a weight. I should have done this way from the beginning. Activated. Fully mechanical latch. We should probably do it this way. A fully mechanical weight activated latch. It's fully mechanical. Okay, sick. Okay. Now we're going to jump in. Now that we have this, everything's set up. Create a fully mechanical. Oops. Oh my God. Enter. Hey. All right, guys. I'm a little frazzled. I jumped into this, and honestly, I don't. Yeah, I don't know. But yeah, we gotta definitely change the font, but I don't know how to. Oh, there it is. Outline. Oh, we'll just give it a background color. Okay. This one. Okay. Background opacity. There we go. And we're gonna resize this thing. And get it out of the way. Where should we put it? Here? Here? We'll put it here. Goal. Okay. Now anyone's gonna ask questions is gonna we can know what they're saying. Are you guys, how are you feeling about the audio? Is the mic too low? Is it good? Thank you. Violet Liar. Thank you. Okay, let's get started. So normally when I start something like this, like realistically, I don't know exactly what to do as far as it's too low. I don't know if I can boost the audio. Oh, I can if I do it on here. Boom. How's that? Is that better? Are we getting better audio here? If not, I'll switch to my other microphone. But all right, let's do this. Better. Perfect. Thanks, guys. I appreciate it. Let's get this. Oh, no, we actually need this. Okay, so what we're going to do first is we're going to do a little bit of sketching. And right before I decided to go live on this, I actually started sketching something. As you can see here. So what we're looking at here is basically like a container, which will be like a cup or something. And I was thinking that inside the cup, there needs to be like a spring, and that way we can control how much weight it requires to trigger this latch. And this is about as far as I got before I was like, you know what, let's go live and do this live. Okay. So, so there's really no specific reason for what this is for yet. I'm still kind of like, ultimately, I think it's going to be like a large scale chain reaction Rube Goldberg machine. I don't know. But right now I'm just like, it's Monday. I didn't really feel like doing a lot. So I was like, you know what, let's just dive into this problem. And like, it's very granular, but we can get a design done in like the next 2 hours, which is cool. And maybe even in our hands, because we can print it really fast. So what we're doing first is we got to figure out how to get weight to trigger a latch. So this spring can be adjusted, and there's the function for the equation for a spring is like, I don't know if anyone knows for sure, remind me, but I think it's like a half kx squared is the force of a spring. And this right here, it might just be a half kx. I don't remember, but it doesn't matter. All we need to know is that by changing k, increasing k, we can increase the force required to squeeze the spring. But alternatively, we can just put 2 springs or 3 springs or whatever. We're going to figure that out after. I might even just use elastics because it's the same equation. And we can just like pile on more elastics. Yeah, I think I will use elastics. I like them more than springs. They're like really easy to use. And like we just like put enough elastics on, we can like really like control the force. What's up, Sean? How's it going? Guys, Sean is he does the live streams for SolidWorks. And so he is he was the one who basically got me started on SolidWorks when I started Engineezy. So everyone shout out to Sean. But okay, so we're trying to figure out how to make this latch, and we're trying to figure out how to get the force of marbles coming down. Can you guys, yeah, you can see this. It's not the best. We're gonna work on the setup as we go, but maybe if I get like right overhead, we'll get better, less glare. There it is. Okay, sick. So, okay, when I talk about spring is literally just something stretchy that, yeah, so it could be an elastic or it could be a spring. But we're gonna use a rubber band because we can like adjust, we can just add more rubber bands. So whenever I say spring, it also just means rubber bands here. And when I show this little drawing here of like the spring like this, you know, this is a spring or a rubber band. And so what we need is for when the ball is to come down, and this is why I really like using this, like just an iPad to do this, because I can just redraw this. And then to show what this looks like, kind of like sprung down, where you're just going to do this, boom. And when that platform goes down, it's going to trigger the latch, and then this whole cup is going to drop. And we're going to basically fill this up with marbles here, like boom, fill up marbles in there, boom. And then that's going to be the weight of the marbles is what causes this to drop. So this is the basic principles of this. And now we got to figure out the mechanism. So the first thing that I was thinking was like potentially, and I don't know exactly how this is going to work, but maybe it's really as simple as this. Maybe it's as simple as like we have these like little latch things that are like holding up the cup, and maybe this latch thing is going to have like a little like, you know, like one of these, boom. And then when this comes all the way down, it's going to push these out, opening the latch, and the whole thing's going to fall. And I honestly think it might be as simple as that. Now the question is, how do we test this quickly? That is the question. What do I think of the A2? Honestly, I don't fully understand the A2. Like I mean, Bamboo Lab is a little confusing to me. They like release a printer, and then a year later they basically release a printer that prices their first printer out of the market. And so I think the A2 is like the H2D without like an encasing, but still really good, that does all the same things. So I think if you're in the market, it's probably a good machine. Although I have things to say about Bamboo Lab, but we're not going to get into that here. Yeah, 3D printer it for sure, but we have to do all the design to 3D printer it. And I think that I might be able to like, We're going to do a little bit of cardboard engineering. You guys are going to come with me here. That's why we got this. Say what up, everyone. All right, we're going to just grab some cardboard and this mat maybe. It's a bit of a mess here, everyone, but just ignore it. We don't have time for cleaning. And maybe I'll pull my table. By the way, guys, this is like my first live stream in a long time, so really bear with me on the jankiness of it, but let's see what you guys got to say. When it goes to a certain cm down, there's a sort of upside down looking L. Exactly. That's exactly it. So the upside down looking L is going to like pop out, and then that's going to cause the whole thing to drop. And now we got to like test the theory pretty quickly. So let's do this. I don't know. I'm still figuring out how to like set everything up. Maybe I just want to bring, maybe I'll just bring the cutting mat here to my table, to my desk. I'm just gonna like push everything out of the way. Hopefully there's no sensitive information on my desk. But if you guys see something, help me out, please. Boom, boom. I'm just gonna get this cutting mat. And just for the record, everyone, this is actually kind of my process as a whole, and it is a little bit this chaotic for the most part, but it's effective. It works. We get things done. Okay. Cutting that on the desk. This we're going to work on. We're going to find a better setup for all of this, but for now, for the first one, Chris, we are making, I'm trying to point to where it is on the screen, but I'm here. Hold on, maybe I got to do this. I put myself, where's me? This, up here, boom, hi. And then this we can actually make bigger because we don't need SOLIDWORKS and this open at the same time because we're in this mode right now. Boom, we're in making stuff mode. So, we'll need some cardboard. We'll use this. This is perfect. Teach me how to CAD. Well, right now we're actually first doing cardboard automated engineering, cardboard aided design. This is actually for nothing yet. But yeah, if anyone asks what we're trying to do, someone else just explain it. I normally have ADHD, so when I'm trying to run a live stream, I'm gonna have to figure out how to best do this, but I do want to do some more live streaming because I think it's fun to hang out with you guys while I'm doing it. Okay, perfect. All right, so we're just gonna do a little test here, and we're testing this concept right here, and I'm just trying to figure out the best way to just set this little test up. Maybe we'll just do that, and then we're gonna make a little L shape here, and we need a boom. Yeah, I like that. Okay. So when I'm doing a test like this, there's definitely a balance between just trying to get something quick and something that is not so quick that it doesn't work. If that makes sense. But because if we test it and the problem is actually that the prototype sucks, then we don't know if it was the prototype that sucked or the idea that sucked. And so we got to get the prototype somewhat good. And I'm kind of doing a quick move here because I really do think that this is going to work. I'm just trusting my intuition, and that comes from many, many times making things and failing things. But okay, so here's the idea. Basically, this right here is the wall of the container. Yeah, that's the wall of the container. This is the latch, and I made this. And this is the latch right here. So that will be able to move like that. And I think we gotta make this a little bit shorter, just a touch. Boom. Okay. And so when that goes like that, this should be able to drop. And the question then becomes, will we be able to trigger that with a platform that pushes down? Guys, I actually think this is gonna work. Bearded printer, I really appreciate that. Thank you. I appreciate this is good feedback. If you guys are enjoying this, please let me know because I'll do a lot more of it. I think that this just suits me better than making videos. I actually think I might have messed it up by doing that. No. Okay, so what we're gonna need is we're gonna need a housing for this to pivot on, right? Kind of like this. That's separate from this. So the thing that the container is sliding on will also be fixed. And maybe we should get the Echo, turn on the glue gun. Echo, turn on the glue gun. Thank you. Okay, glue gun's on. I'm gonna try to make a little guide. So this is gonna slide like this. Technically, I'm gonna remake my container to look a little bit more like a container, I think. Never mind. You know what, guys? Screw this. we're gonna jump right into CAD because I think this is gonna work, and so we might as well just like, I don't know. We're jumping into CAD, okay? We're gonna do this, and just so everyone knows, I don't think that I'm gonna get this to work the first time, okay? Hansy, imagine that, eh? Imagine. Yeah, Echo, turn off the glue gun. It's off. You know, it's funny. I've left that glue gun on for entire weekends before. So the reason why I connected it to Echo in the first place was purely because it turns off at 11 o'clock at night every single night. So I never leave it on overnight anymore. Cardboard modeling is definitely greater than 3D printing, except for right now, because I just really think that I know how to do this in full. And so you guys are going to join me for the process. Okay, let's get this. We're going to go out of this, and we're back in SolidWorks. We're going to move this out of the way. And all right, guys, you ready to go a little crazy here? Let's do this. So we're going to start by designing the container, I guess. And we got a new part here. And we're just going to keep it really simple for the time being. Let me know if you guys want to see what I'm doing on my keyboard. Let me know, and we can set the camera up on that. Coder Chit, thank you so much. Really appreciate that. Okay, you know what? I'm going to set it up so you guys can see what I'm doing on my keyboard and mouse. Because yes, there is a thumbstick there, and I use it to, how do we get a good view here? Maybe we'll go like this. You guys won't be able to get a great view, but you'll see a little bit of my shortcuts and stuff. Boom. Max, I don't know when I'm going to post another long form video. Honestly, I've been a little bit out of the making long form video mode, which is actually kind of why I'm streaming now. Because I think that this is just this is better. It's more fun. You guys can hang out with me in real time. Then we can just post some shorts together and, I don't know. Yeah, I don't know. Okay, just so you guys can see my keyboard. Because I do a lot of shortcuts and stuff. So, and I'll call out some stuff. But basically, we're going to make a square or rectangle. And Q is my shortcut for dimensions. And then there's a lot of time, when I'm designing, I'll just grab my calipers and kind of figure out how big I want something to be. So we're going to go with I don't know. We'll go with 50. 50, boom. And I also have this other keyboard, which I keep here. Because generally, I like to keep this hand on my mouse at all times. And so when I'm doing numbers, I'm often on this half of the keyboard. But yeah. Thank you, everyone, for the love. Whether it needs to be self-resetting, I think we're gonna make it manually resetting right now. The number of marble. Listen. I don't know any of the details, but we're figuring it out as we go. But right now, we're just gonna make a little prototype so we can see if this even works. And we'll start by doing it in CAD. And we're gonna make this. I don't know. Let's call it 75 tall, and we're gonna shell it out. And just so everyone knows, there's a million ways to do the same thing in CAD, and I barely ever use a shell tool, but today I'm using it. I don't know why. And we're just gonna live with it. Okay, so we got that, and we're gonna do a quick SolidWorks prototype first. So we're gonna make a new folder for this. That's 201, and we're gonna call this Weight Activated Marble Latch. I don't know. I always use 4 words for my titles, and then that way. Oh, I didn't save that yet. That way, I'll show you why, actually. So now we're in Weight Activated Marble Latch. So the title of this is going to be WAML_assembly. And then this part is going to be WAML_, we're going to call it marble container. I don't know. And just for the sake of having a base part that we're going to slide on, which I'm thinking I'm going to use, maybe I'll use a linear rail for that just because it's easy. and legit. So I already have some of those in my parts behind me here, and I already have designs of it. And this is actually where life gets really, really quick and easy for me, because I already have everything designed from previous projects that I can just like pull different parts from previous projects. So right now I'm just in my file system right here. It's a mess. I don't want to show it to you right now. It's a little embarrassing. But linear rail is what I'm looking for, and it's going to pop up in one sec. MGN9, that sounds good. Boom, and I'll show you what I'm doing here. What I always do is I copy it into the folder I'm working in, and this is not like, one day I'm going to make an entire catalog of all the stuff that I work on, but for now I just find it's really easy for me to search. But let me know what you guys think of this, actually. I was thinking of putting together an entire catalog that links to all the parts that I normally just buy everything from Amazon. So I would basically just link to all the parts, and then there'd be CAD that you can pull into your whatever CAD you're using, and then you can just buy the parts from Amazon. And I probably would just like link to my affiliate link, but at the end of the day, it makes no difference. What do you guys think about that? So like stuff like this, like my linear rail here, boom. So I already have this open, boom, just like that. And this part exists on Amazon. And so you could just basically grab this from Amazon, and we need the slider. So we're basically building a mechanical scale, right? Technically, that's what we're doing. I think like for a lot of the stuff that I make, like just use a mechanical scale, like, yeah, I love the suggestion, but it's hard to find like it's not like something that's just like that easy to find, right? Okay, so we got our slider and we got our rail, and this slider is actually going to be attached to the cup. And often when I'm in a situation like this where there's two parts attached, sometimes I'll just do this. I'll pull the part in for the slider into this part, because it's going to be attached anyways, and so I might as well. And basically, I use SolidWorks, right? Like I've always used SolidWorks, but a lot of what I do can be translated to other CAD softwares, like Onshape or Fusion, or I don't really know like if there's anything else worth learning other than Onshape or Fusion. But if you guys use something else, let me know. But for now, this is good. We're just doing a quick like SolidWorks prototype, which I'll probably end up cleaning up later off stream. But for now, we're gonna build everything off of the rails, like our fixed point, and I don't like the way that it's oriented right now. What's up, San? So Blender is different. Blender wouldn't exactly work the same. Oh, we're actually good. No, that's the top plane. So we want this and this, because we want this to be vertical. So basically the cup is going to be dropping down on this right here is the plan. But yeah, Blender is a little bit different. You can still do mechanical design in Blender, but yeah, it's a lot more for rendering and animation. It's a different process. It's a different process. But I guess if there's plugins for precision work, it'd be kind of the same. I don't know. I learned Blender once and then like never used it, and then totally like forgot how to use it. So I'm a SolidWorks guy. All right, let's get the container in here. Boom. And this is all going to start to make sense quickly when we just do this. And we're not going to be precise here right now, but it's good enough. Boom. And we're going to do, I never used to use these width mates, but now I do, and they're freaking awesome. Boom. And this and this. Boom. And look at that. Now we have a cup that slides up and down, and the marbles are going to go in this cup, but in this cup that slides up and down, now we need the platform that is on spring or elastics. I think we're going to use elastics, like I said. So let's make that, and let's just see what our inside dimensions are here. Boom. 46.8. So we're just going to do this. make a new part, and this is going to be on the top plane, even though it's kind of arbitrary which planes I draw on. And we'll make this 45. And I can't remember what my other dimension is, but it doesn't matter. We can fix it later. So we'll just call this 50 for now, and we're going to make this like a 2.5. Boom. And we're going to call this WAML underscore marble. We'll call it a scale. There you go. I have the like pro. I don't know what license I have, but I have the top license. I'm actually sponsored by SolidWorks. Like, they sponsored me a license, which is incredible because otherwise I would have probably just paid for it. Did I make this square? I guess I did. 46.8. 46.8. We're going to go to assembly, insert component, and we need to scale. So a lot of questions like, why am I not just using something that exists already? Because nothing that exists already is going to like function the way I need it to. Exactly. I mean, I could work around it, but I could also design it and 3D print it myself. So that's what we're doing. That's the fun part. Boom, we'll set that up. I mean, there's like, again, a million ways to do the same thing, but now we're doing it this way right now. I don't know why. Boom, and obviously this is a little too big, so we're gonna make it a little smaller. And I'll make this transparent so we can see. And so look, this now moves up and down inside the container. And for now, we're gonna fix this in space. Boom. So this, I fixed the wrong thing. Float. We need to fix this. Oh, that's already fixed. Okay, perfect. So that's gonna be the thing that the marbles drop onto. For tolerance, we'll get into tolerances actually, but right now, right now, actually, this is a perfect situation to look at. So this is a lot of tolerance right here. We're looking at over almost more than a millimeter. I use millimeters. For like, it's different depending on what we're doing. But in this case, where I have this thing that's like free sliding inside something else, like this is too much tolerance. There's gonna be like a little bit of like wiggle. You know, it's gonna like wiggle inside the thing and it's gonna jam, but we're gonna fix that also. But for now, we're just trying to get the latch. So let's draw the latch next. New part. And we're gonna go on the front plane, boom, sketch. And the latch is gonna look something like, boom. And we're gonna, maybe the latch will just be like a we'll use a 4 millimeter screw for the latch. So here's something, sometimes where I'll like bake in the tolerances. This is gonna be like free rotating. Like, I keep trying to like point to my screen and show you what I'm doing here. It's gonna be free rotating on a 4 millimeter M4 screw. And so we're just gonna do that for now. And this is all gonna be arbitrary dimensions for the time being. We can adjust it all later. Thank you. Yeah, if anyone's coming to open source, let me know. It's gonna be a lot of fun this year. We're just gonna make this, and then we have a couple things we need for the latch. We need just like random L thing. And again, if anyone's wondering why I'm doing something a certain way, and they have a different way that they would have gone about doing it, your way is probably right too. And it's simple as that. There's a million ways to do the same thing in SolidWorks. So, in all CAD, honestly. So yeah. And also like what I'm doing here, I'm kind of just vibing. This is just what feels right to me. Up to surface, boom. And then we need the like trigger thing, which is gonna be here. And I don't know the best way to dimension this right now, so I'll just dimension to here, and we'll make that 1.5, and we're gonna make this some arbitrary angle, which is 25 for now. I like that. And this is the last thing we need, and we'll go to here, but I don't know. Again, I don't know where the best way to dimension this is, so sometimes I will dimension it this way and then I'll change it later. I have used NX before, actually. My first year of university, we learned NX. Latch arm. Yeah, always fully constrain your sketches. And that's like something like, even when you're like so lazy and it's like hard to convince yourself to do it, it's still worth doing, always. Okay, so we got this latch here, and just so this starts to make a little bit more sense, I'm just trying to think, did I miss something? No, I think we're good still. Okay, insert that latch arm, and this is going to be fixed on this. It's going to sit kind of like right here, and it's going to rotate on something. And so I'm actually going to draw that directly into this part. And right now we're just prototyping, so I'm going to just like make it really prototypey. And so the thing was 20, boom, 25, boom. And we're going to put a circle here. So like, as you can see, I'm not even like really thinking too much about this. I'm putting dimensions so I can adjust them in the assembly. And this we're going to, just for the sake of scale, 4.5. No, we're going to screw into that. So 3.75. As far as dimensions and tolerances go, when I'm threading directly into a 3D printed part with an M4 screw, I'm always gonna make the hole 3.75, and it comes out of the printer at like 3.5 or even 3.4, so smaller. So that's rule of thumb. And like, if we keep doing these streams, you will see my rules of thumb are pretty consistent. And I think there's two reasons for that. One, obviously I've just done this a lot, but two, using fixed dimensions makes the decision-making process a lot easier. Like a million times easier. So that's the main reason. Like, so like a lot of times I'll use 2.5 for like a wall thickness. And when we look at how that prints on a 3D printer, we're gonna get to that. We're gonna get to all of that. Sorry, I don't wanna get too ahead of myself here. Just bear with me. If you have questions and I don't answer them, just like, we'll come back to them. But okay, for now, yeah, Aldi no Zeno. There's actually no spoiler for this project yet because there's no project exactly. Right now, it's just as simple as I just want to make a latch that, like, when I dump a bunch of marbles into the container, it unlatches and drops, and then that can do something else. That's it. But yeah, a lot of nuances to design for 3D printing. And the nice thing is actually using those nuances it constrains your design. Because like, technically I can make this any dimension I want, right? But if I make it 2, and I'll show you this later, but if I made this thickness 2, the way that it prints is a little bit weird. If I make it 1.8, that ends up being 1, 2, 3, 4 layer lines on a 3D printer, and that's actually very clean. 2.5, you get 1, 2 layer lines, then like a thick infill, and then 1, 2 layer lines on the outside. So stuff like that is actually like pretty important stuff. Will I upload this mechanism? I don't know, because you'll see here, like when I design things for myself to build, it's very different than designing them for other people to build. And right off the bat, you can see I put that in the wrong spot, which is so classic. We're going to we want this. I think really the problem is actually that I put this in the wrong way. So let's just do this. We're going to get rid of that. We're going to suppress that for a second, and we're going to flip this. Boom. Now it's in the right spot. Look at that. And then we'll unsuppress that. Okay, and now we can attach this to here with a mate. Boom. And for the sake of just quick prototypes, we'll put that there. Boom. And if I'm moving fast on this stuff, like, let me know, and I'll try to like explain a little bit more about what I'm doing. But we're trying to get the build out and working, and then we can get back to it. So this is the view right here where stuff is interacting. This is called assembly mode. So you can see, like, see how this is doing this. That's because I just added mates. And the mates allow this to rotate like this. That's what this, if you look in here, and you're behind, you can't see what I'm looking at right now. Hold on. Let me just move this. Let me try to move this up so you can see it. You know what? We're just going to hide my, boom. So right here, see how there's mates? And like this latch arm has 2 mates. One is constraining the circle of the latch arm to that circle of the part that I just drew. And then this one's constraining the surface to the surface of this part here. And so it's basically like doing Legos in like the virtual world. And now this moves like this. So it's obviously in the wrong spot, but that's where the fun part of this goes. So like if you remember, I said before that I put some like quick dimensions in. Now I can just double click this, adjust this dimension, make it 30, rebuild it. Now it's out here. It needs a little bit more space, 32, rebuild. That looks pretty good. And then now technically, if I float this, we can move it down to here. And this is where it's going to sit. This is going to be held on this. And this is where my logic breaks. So basically, if this latch is held down like this, nothing's stopping this latch from doing this. And then this is where now we're in the brain hurting mode. Okay, now we got to think through this. Mates are very similar to joints and fusion, but they're like same but different. But it's kind of the same, but it's also kind of different. I actually don't know enough about fusion to talk about the differences between this and that. But one thing I do know is fusion is like you kind of build everything in the same file, where in SolidWorks, you're building everything in separate files a lot of the time. And the way that I typically do things in SolidWorks is like, if there's a part that's made up of a bunch of different parts, I'll put them all in the same part file. But if there's stuff that moves, it will often get its own file. So, okay, going back to this, like original logic was this is going to be like latched on here, and this is going to come and push down on this. That's going to push this out, and that's going to drop. This is all going to be combined. Like this is going to be on a spring inside the container. But this logic isn't good because nothing's going to hold this latched. We need something to like latch this. I like literally never use 3D sketches actually. The only time I use 3D sketches is like when I'm doing something like just like a crazy surface modeling or something. And yeah, I'm going to 3D print this, but we first got to figure out what mechanism we're even going to use. So we're not even quite there yet. That's why I made this really quick prototype. So a rubber band would hold it in for sure. If you have this slide out, but it's the same problem. We need some way to like contain it. Okay, this is kind of what I'm thinking. This is what I was thinking, was basically the idea is for this container to stay in the exact same spot until the exact right amount of weight's on it, and then boom, it's gonna be gone. So it's like a trap door. So if there's a latch on a spring that slides instead of rotates, it's kind of the same thing. We need some way to activate that slide. Okay. It's kind of coming to me, I think. I think it's coming to me. Okay, this is where we're going to go to sketching mode. We're going to get into sketching mode. Sketching mode. Opposite latches connected with a spring. I think we're kind of thinking in the same way here. Let's see. Let me activate sketching mode. We need this. We need this. We do this. Boom, sketching mode activated. Look at that. And okay, so here is the Earth. Damn, that is one sweet Earth, you might say. Cantle. How does this look to you guys? That's pretty good. All right. So, yeah, this is just an iPad, but it's also my drawing tablet, which is it's funny. I bought this iPad specifically to be a drawing tablet, which seems like a little bit overkill, but like all the drawing tablets were kind of, I don't know, the same. And like this just allows you to do some cool stuff. So, okay, opposing latches. And they slide outward instead of inward. But here, maybe this is what you're thinking. Maybe it's not. But basically what I'm thinking is, I was originally thinking that these would be like pushed out, but maybe what's happening is the spring, there's a spring that's holding latches. Yeah, see, sliding was already originally in the thought process, but oh my God, it's really hard to think and do this on live stream. But we're gonna get this to work. Hold on, it's gonna come to me. So what I'm thinking is, rather than this being pushed out, maybe this platform is always gonna be holding them pushed out, and then when they push in, yes. Okay, so let's get our cup. We're gonna duplicate that. Duplicate that, and we're just gonna bring that there. Come on, there we go. Oh, no. Okay, so now we can get rid of this, and this, and this, and this, and this is gonna show the platform as down. Oh, but we're redrawing the platform actually, because the platform needs to have, I'm going to draw the platform in blue. It needs to be like this. It's kind of like a cup inside the cup is what I'm thinking. And we'll just keep the spring like this. And then this is going to be in the second state, which is down here. And so the latch is going to be like over here, we'll call it. So right now, the latch will be, let's see. That's when it's at its low state. At its high state, it's held out like this. And then when it pops in like that, what's going to happen is this is going to be tied. We're going to draw in purple kind of around the back to, I don't know, a platform like this for now, we'll call it. I don't know. This is confusing, but it's going to make sense. I promise. Maybe we'll draw this latch here. Boom. And then we'll tie them to, oops. I just want to make this easy for me to copy and paste. So we're going to draw this as a single block. And then this will also be a single block. And then we're going to try to copy all of that. Hey! Duplicate. Okay, are you guys ready for this? Grand reveal. So this is going to be here, and as you can see, it's kind of like holding the cup. But then when this pushes in, boom, the latch at the bottom allows the cup to drop. Does that make sense? Do you guys get what's going on here? If not, don't worry, because we're gonna do it in CAD now. But I do think that, okay, just for the record, I will say I do think this is gonna work a lot of times, and then realize later that it's probably not gonna work. And I think just like a little bit of this like kind of like blind confidence is important because this stuff is hard. So, all right. Sensor would be best. Yeah, I mean, if we're using electronics, but we're trying to be fully mechanical in this. So the sensor has to be mechanical, but don't worry. Don't worry. We're going to get this to work. You know what's interesting actually is like a lot of this came from self-nerd. How I connect the spring, that's going to happen in the back. Let me draw that part out, and then maybe it'll start to make sense. Honestly, one day we're going to get a Tesla robot to do all of it for us, and then the internet's just going to hate me for using robots. They're going to be like, bro, you should have hired an engineer to do it. Or something, I don't know. Okay, let's draw that sliding latch. For now, we're going to just do it really crude. Remember, this is a prototype. So we're going to start by doing the connector. Just trying to think about the best way to do this. I honestly only ever really use SolidWorks desktop. I haven't really messed around with the 3D Experience platform too much. I was at 3D Experience World last, like in February or whenever, maybe it was March. I think it was February. And I saw some of the stuff that people were doing in the 3D Experience World stuff, like software packages, and it's pretty cool actually. So, I mean, there's definitely a lot of stuff there, and it's browser-based, which is cool. I mean, I'm on my desktop right now, which is a Windows computer, and I don't love Windows, to be honest. Like, I'm more of a Mac guy, but I can't use SolidWorks in Mac. So it would have been nice to have been able to do this on Mac and not have like 6 computers on my desk. But WAML, we're going to call this sliding latch. And on the bottom, we're going to just put a little... This is going to be one little latch. Boom. It will be able to reset, and we can design it eventually to reset like automatically. But ultimately, if this is going to be like a, I don't know, like a Rube Goldberg machine, I think, like, I don't know. We're going to figure it all out. We're going to figure it all out. And another thing, just like, so everyone knows about my process, is like I might design this way right now and then realize in like a day from now that I did it completely the wrong way, or there's a better way to do it. But sometimes you got to just get there first. And so that's what I'm trying to do. I'm just trying to get there. And so I'm designing it the way that like made sense to me originally. And that making sense to me originally is like it comes in like weird, like, you know, like it comes in like unclear like pictures in my brain, and then the only way to clear it up is to like put it out into the world. So, okay, so here's a very like crude version of the sliding latch, and right now it's not even designed well for like printing or anything, but we're just trying to do like quick prototypes here. So okay, this is gonna sit like this, boom, and we're gonna put this, like obviously like none of this is gonna work right now, but we're gonna figure it out. We're going to figure it out. So just bear with me. Everyone, just want everyone to understand mainly that this engineering is a process. And what you see in the final video and what you're seeing right now are two very different things at very different points in the process. So, yeah. Use magnets with enough force. Ooh, Odin's dad. Oh, sorry. I didn't know that came in next. Mech Austin. Using magnets with enough force to hold until it falls is a very interesting prospect here. You might have just broke this entire thing wide open, but I still want to finish this concept and just see, because I do like mechanical components that move. I'm not really like a, you know, when I started doing like Engineezy, basically, I did it because I wanted to be able to design kind of like things that never need to exist in the real world, if that makes sense. Like, yeah, magnets would definitely be the move, unless there's some restriction on magnets. But this weird sliding latch thing will never have to exist outside of this. So, although I do really like that idea. Okay, here's the concept. And we gotta make this a little bit smaller. Get 70 maybe. So here's the concept. So this will sit on top of this. See how it's on that latch there? Like it's sitting on this bar. And then when this moves this way, like this whole thing drops down like that. And sound effects are incredibly important when you're doing mechanical prototyping, just so everyone knows. And then this is going to be the thing that triggers the latch. So how do we do that? I guess we'll just give it some sides for now. Man, magnets are very, 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 very smart thinking. I actually don't go to magnets often enough because I get carried away with these like fun mechanical solutions. Maybe we'll end up using both. Maybe that's what we're gonna do. And I just want to make sure I did this on the right spot because I often do. We're good. And we're just gonna go in and we'll just make it an arbitrary thickness, and then we're gonna mirror that. Boom. So make this a little bit smaller. This is SolidWorks is what I'm using to do this design. Okay, so the idea is there's going to be a spring that is pulling this way. And it's going to be sitting against the inside of the container, like just like this. And then this right here is going to be on springs to the bottom of the container. And we're going to obviously have a slot here to allow this to slide, but and this is all going to be smaller probably than. But this is the trigger bar right here. And then when this gets heavy enough, it's going to keep dropping until it gets to this point. Boom. This is going to pop this way. Boom. This is going to slide down. Let's go. I think this is actually going to work. I've said that before, but I'm saying it for real now. So, okay. Why am I not using Fusion 360? Because I've always used SolidWorks, and they kind of both do the same thing. By kind of, they actually do the same thing. Okay, so there's a couple of things we still got to answer, but for now, I just want to start refining the design of this to better fit. So we're going to say maybe we need like this much travel. That's a lot of travel, but it probably will work. Honestly, not just sponsorship. I used SolidWorks before I was sponsored by SolidWorks. In fact, when I first started Engineezy, I reached out to SolidWorks asking if they would sponsor me, and they're like, "Who is this guy?" I was like a no-name at the time. But yeah, we've come a long way. Okay, so one thing that we got to think about is the way that this is currently set up is not going to be great for like sliding. Maybe we want the this whole latch thing to be. So the whole latch needs to slide this way, but it's got to stay fixed relative to the thing that we're mounting on, which is, for now, is going to be this. Thank you, Flo Lorenzo. I appreciate it. But yeah, so this needs to stay fixed. This is obviously way bigger than it needs to be. And we'll just start with this. And we're just going to give this a dimension. Really, this technically should kind of go, whatever. We'll just leave it at this for now. We'll adjust it after. What we need to figure out is how to get this. Maybe what I'm going to do is just make this shorter. But it's all going to have to live behind this. What's up, Undercharge? This whole sliding thing will have to live behind this linear rail, which is fine, I guess. Just like slidey things bind really easily. Guiding rails, yeah, I don't know if I want to use another linear rail here though. I think I can just get this to slide for the first prototype. We kind of need to prove this concept first before like bringing in like the real big dog components. The linear rail is there. I don't even know if I'm going to use that. I might just use Undercharge. My advice to you is to just do it. I honestly didn't even go to school for engineering when I first started university. I switched into it. So, yeah. Do it, and you'll learn a lot along the way. It's not going to be easy, but it's worth it. Okay, I'm going to just give myself 3 minutes to think about this. And I apologize for the sake of the stream, but like this is where engineering live streams, like literally a lot of the times I'm just like twirling. I'm just like literally doing this. So you guys are about to see this happen in real life, but oh, Mech Austin, let's see what you got here. You got some good stuff here. Tightish elevator like shaft. There's a blower air pump. Oh my god. Now we're getting into pressure. That's gonna be dealing with pressure and blowers is like such a pain in the butt. I like mechanical stuff because it's very exact, and I mean, it's not very exact, but it's very exact for like what I can do with 3D printing and for what I can make in my shop. So one thing that's like a very key thing to my entire process is using stuff that I can easily make or acquire for my designs. So little sidebar story, but I was working at a toy company before I was doing this. And there was a guy at the toy company who was this like cracked mechanical designer. He came up with the wildest ideas, but half the time, like he would like design something that's like a triple threaded custom part that we yeah, we could probably figure out how to make it. We had some CNC machines and stuff, but like there was just it was just unnecessary for like how intense it was going to be to manufacture. And so I really kind of I'm like a little bit lazy when it comes to that kind of stuff. So like everything I do is like 3D printed with my FDM. Like I use regular Bamboo Lab or Prusa printers, or like mechanical components that you can get from Amazon, which is extensive. The library of things you can get from Amazon next day is extensive to the point where I'm never making designs where I necessarily need to like find some sort of like external vendor to help me make them. And interesting about James Bruton, but James actually operates on a similar principle, which is that like if you see a lot of what he designs, like he's using aluminum extrusions. Like if you see this thing behind me, can you see this, what I'm pointing at? Yeah. Like everything is just like aluminum extrusions and like, I don't know, just like stuff that you can get off the shelf. And it just makes the process of prototyping really quick and easy. So yeah, that's kind of my rant on that. Let's get back to designing quick prototype, because honestly, we might be able to even like get this printing and then test it on stream, which is kind of cool. But the main challenge right now we need to figure out, so this is going to drop, we know that. The main challenge we need to figure out is how to get this latch to slide nicely. So basically, for anyone who's just joining us, the idea is this is the latch. It's going to sit here. And this is going to be on a spring or elastic band here. And when it starts filling up with marbles, it's going to start dropping, 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 dropping until it gets to this point right here. Boom, where this is going to latch forward like this. And then the whole thing is going to drop down like that. Okay. I mean, bistable mechanism is also a really interesting concept. But the thing about, here's what I'm really, like my head, what I want this as the designer to do is I want this whole thing to not move at all. Not at all until I want the whole container not to move until the exact right amount of weight gets in there. And so I think that this is the way I want to do it. Spring loaded. Okay, let's do a couple things. A couple things we need. First things first, we need a way to like put this on elastics. So let's just do that first. And to do that, I'm just gonna put like a couple little like hooks on here, and we're just gonna hook them on. And we're gonna make it really simple, because this is just a quick prototype. We want this to print in like really a short amount of time. So I'm just gonna do this, boom, boom, boom. And we're gonna do this and this, and just dimension this whole thing. So let's go with, yeah, that's, maybe we'll go 5, and we're gonna have this stick out 5. And a lot of times I kind of make this up, it just looks right. And then we're gonna go from here to here. Yeah, that looks good. Boom, grab that, grab this, mirror that. Boom, grab this, mirror that. And extrude down. I'm just gonna go 1. And so this is where right now I'm thinking about how to design for printing. And so that's why I'm doing it this way, and then I'm gonna just put a chamfer on this. And so this is This right here is going to be the bottom. This is going to be on the bed of the printer. And then this is going to be on the top, but these can be an overhang. So the outer shell is going to drop with that inner like moving thing. It will start to make sense really soon, I think. Boom. And I think this is sticking out way too much, way more than it needs to. Boom. And then, okay, that looks good. And then here we're just going to put some little nubs so the elastics don't fall off. And you know what? I think that I made this a little thicker than it needs to be as well, but we'll fix that. I'm just going to do this. Control E, make them all equal. And as you guys can see, I like to move really fast in SolidWorks. Sometimes faster than SolidWorks allows me to move. But part of the reason I'm able to move so fast is because I've just done this so many times. Okay, so the inner box is going to go, so we need a couple slots for the inner box. And those are going to come off of this right here. And the slots, just for the sake of ease, I think I'm just going to make this a screw. And that looks good for now. And we're going to go like this to here. Nope, that's too much. Actually, these are too big. We'll come back. We'll fix it. We're going to fix it all. I think I'm going to make this whole thing smaller so it prints faster. .5, boom. Okay. I use millimeters because I'm in Canada. That's just like what we learned, and I just think that it like makes. No, I'm from Canada, but honestly, a lot of engineers in America learn millimeters in school as well. I think for engineering, it just makes a lot of sense to use the metric system because like things are in tens and I don't know, like liters and millimeters and milliliters and weight. All of it just makes a lot of sense. Let's grab that, do that, cut that through all, boom. Okay, so now we have our box. Yeah, okay, that's good. Okay, I think I might have gone the wrong way. What just happened? That was our latch. How did this flip? I don't know, but we're gonna keep going. We'll figure it out. For now, this is the right way. Okay, so on this guy, this is our inner thing. I think what I'm gonna do with this is I'm actually just going to make this like a little inside container. So I'm gonna extrude it up as a thin feature with a 1.6 millimeter wall thickness. And now is actually a good time for me to show you why I'd be going with 1.6 over other random dimensions. We'll make that 15, 18. And I need to be able to put some screws on the side of this. So I'm actually going to make this a little bit thicker at the bottom. It's 2.5. I'll make it 4. And we're going to put a couple screws in. The middle there. And I'm going to be using some probably number 2 self-threading screws. So yeah, that's why I'm going to make this whole dimension like 1.85, and that should work. And this has to be the same distance that I made the slots, but I can't remember exactly what I made them. So we'll just do this for now and we'll fix it after. And that's going to go in blind 10-ish is good. And we're going to mirror that. And there's a good chance, there's like a rule actually. The rule is if I choose a face to make a feature, now I'm going to go into the assembly, watch this. Oh, and it's on the right face. But there's like a 50% chance that I made it on the wrong face, and there's like a 90% chance that I did it on the 50% wrong side. Okay, well, I have the whole inner thing drop. So here's the whole principle of this. The whole inner thing is going to be on springs or elastic bands. I keep calling them springs, but they are going to be elastic bands. And this is going to be, so there's going to be screws coming out of these holes, and then there's going to be an elastic band that's wrapped around the screw and around this. So I'm obviously going to have one on each one. So this whole thing can move inside the container And the reason why that's on elastic bands is because I can adjust, by adjusting the elastic bands, the weight that this thing moves on. Okay. And yes, you could open part in position, and I think I'm just in the habit of not doing that. But yeah. Like, yeah. I mean, I could just open part in position. And what we need here is to make sure this is 30. Oh, I went 35. I like the number 36, so we're going to go 36. So that's why the inner, yeah, so the screws are going to screw into the inner guide, and that's going to just allow me to wrap an elastic, and that allows this whole thing to flow. So now let's just optimize, like this is just way too big for what we need for the sake of this test. It might not be, honestly. I don't know how much weight we're going to need for the elastics, but the other thing I want to optimize is like there's just a little too much space in here. So inside dimensions are 46.8, and I kind of want 0.2 on each side. So, and yeah, you can also edit the part in the assembly, but I find that I tend to get like a little confused when I do that. Okay, so it's 46.8, so 46.8 minus 0.2 minus 0.2 for each side. And now you can see we have 0.2 on that side. And sometimes I will modify in assembly because we have this, but these just need to be equal. Boom. And now we get out of that, save, build. And now this should just slide nicely inside the inner container. And that should be no problem. Okay, next thing we need is to figure out our latch. So we need a way for the latch to slide on the back thing here. And what I'm thinking, just for the sake of ease, sometimes, you know what, I'm gonna draw it up because this is the best way to do this. The screws won't be, I mean, the screws will be tight into this. Okay, let me answer some of your questions, then we can see. Magnets on top, yeah, the magnet idea is a really great idea. I think we might have to explore that as well, but for now, we're gonna explore this, and then maybe we'll make the second one, and then we can actually make a video about both, and that's great, more content, right? Because we are making content here, and we're trying to make viral content here while doing fun stuff. Just so everyone understands, like, you know, Engineezy is a media company, a content company, and that's why I like to do stuff, because like we can make a video basically comparing this to magnets and see which one's better. And just so everyone knows, like while we do these live streams, like you guys are like you're in with me now. Like you're in the shop with me. So we're thinking the engineering, but also the content creation side. And so you guys are gonna like be like behind the scenes with me, and you're gonna know like firsthand, like if a video bombs, we bombed on that together. So, yo, what's up, MTV guy? I don't know how you guys feel about that, but the content's definitely like the way to fund these like fun projects. So it's just kind of part of it. Okay, this thing needs to flip. Boom. And now we're back in business with directions. And just for the Eric, okay, let's do a quick recap of what we're building. So we're trying to build a latch and container. This container right here drops, and you know what, just for the sake of this, we're gonna just do a quick man, sometimes dealing with, I just want to constrain this quickly. Boom, to there. We're going to do a little bit of distance. Okay, and we're going to make that transparent again. Boom. Okay, so the idea is this. This is a container, and this container is going to be like attached to a rope up here, something like this. I don't auto-save, but I'm very good at control S-ing. So we do a lot of saving. Okay, sorry guys. I have ADHD, so if I'm jumping all over the place, just bear with me. We're gonna get to the point here. The point is, we are making this container that when this container drops, is gonna cause some action up here. And I want this container dropping to be controlled by like a stream of marbles, small marbles coming in. So just to recap, we have like a big ball. This big ball is going to be the thing that is like it's on its like main quest, like it's on a journey going through some random system which we don't know yet. And the small balls, which I don't know where that went. Oh, here it is. Oh, sorry guys. The small steel balls are going to be the balls that trigger the actions along the way. So basically, when this thing fills up with enough small steel balls, this thing right here is going to drop down to, like, let's just call it like this, boom, like that. When it drops down, because it's on springs, so the more weight you add, the more the springs are going to stretch until it gets to the point where it drops to here. This latch is going to pop this way, boom, like this, where it's going to release the bottom of this container, which is then going to allow the container to drop. That's the idea. Stainless steel marbles. Well, you know what? The magnets would work if we just place everything in the right spot. But I like mechanical solutions because I like things that slide and latches, and I don't know. I just like this. So we're just going to go with it for now. Okay, so next thing that we need to do is figure out like the proper way to latch things. So let's go back into sketching mode here. And let me get the sketching mode open. I think I need like a Steam Deck to do this easily, right? I don't know. So this is often what I do is like I make really sketchy sketches, but they kind of teach me what I need to draw in CAD. So here is our linear rail. And everything's going to be sliding on it. But behind the linear rail is going to be our latch. So I'm going to make the latch in this red. It's going to come like this. And like this. And then like this. And that's going to latch onto here. And to print this, we're going to print it this way. So that's just how we think about, that's how I like to think about things. And that means that like this is going to either be a separate part that we just screw on, or I just use supports. I don't know. For some reason, I'm still very anti-supports, even though like supports are good now. Like when I started 3D printing, like supports were like a no-no. You put supports in your design, it's going to be the biggest headache, but now they're really good. So yeah, I don't know. The upper latch part is, so I'm going to make a slot, and that part I figured out. I hate supports too, but sometimes trying to, print in multi-part and then assemble later, it's just more annoying. And like, there's just sometimes no point. But this is what we're going to do. For this, so this is going to be sliding. It has to slide this way, right? Back and forth. We can erase this. It's going to be confusing. And then we're going to print like a back thing that this is going to attach to. This is going to be like our stand. You know what? We actually don't even need to do that because I'm going to probably just attach it to an aluminum extrusion. So this is just going to go on the back. Okay. So you guys, I get about to here, and then like I now understand what I need to do in CAD. So we're going to go do that. Okay. Back into CAD mode. Okay. Let's talk about best idea, easy to calibrate. Like maybe magnets are the best idea, but magnets are not like that easy to calibrate. You got it. I mean, I guess they are. You just add them. Oh, screw them in and out, whatever. Although, like, I don't know. What if you're just not allowed to use magnets? It's such a stupid thing to say, but like in like the toy industry, for example, like we weren't allowed to use magnets for most things because magnets are a bit of a liability for kids. So yeah. Yeah. All right. We're doing it this way mainly because I just think it's going to be cool when it works. And that is like the main reason why I got into like engineering for fun, basically. Like making content is the business, but outside of that, I don't have to justify anything, right? So yeah. Thank you so much, Super Valid Designs, for watching from the beginning. You've definitely seen my entire arc as an engineer and content creator, and it's been quite an arc. So anyways, we're going to get back to that. But for now, let's just try to get this. Let's just get something on the printer. So here's the idea. This is going to slide behind the linear rail, just like that. And that looks like it should be fine. should work, and we'll adjust the dimensions after. But for now, I just want to get the little sliding support thing. Mechanical movements are satisfying. They're just so fun. Okay, so on this thing, we're gonna like basically draw the sliding support thing, which is just gonna look kind of like this. And we'll screw it into these holes here, like this. And we'll just center it around one of these, but we can move it on any of them, which is nice. So that's gonna go there. And that's gonna be like whatever dimension we decide. A lot of times when I'm just doing quick prototyping like this, I'll just make quick dimensions and then like figure it out exactly what I need later. And this looks pretty good. We'll make a hole for this here. And then I can't remember what these holes are. They are 3.5. So I'll make this 2.75 because we're going to probably screw through. I'm on the wrong side. Let me just adjust it to the other side. Because we're going to, you know what? Let me grab the linear rail so we can get a better idea of what we're trying to do. And I think it's in here. I gotta say, I absolutely love like having a collection of like, oh my god, mechanical components. Like it's just so fun. But you can see this is the rail that we're using. Hold on, let me get the webcam view up. No, this one. Okay, so you can see that this is the linear rail, and it's got these like holes with these counterbore holes in it. So we're gonna put a screw in from the front, and the rail will slide. It slides on this section right here. And you know what? We can actually open it up and just get a better feel for it. Beauty printer, that is like 100% right. If you don't have constraints, it's honestly like you can get really paralyzed. For me, my constraints are often like, I guess, off-the-shelf components or stuff that I can 3D print with FDM, and then like design for like really like easy assembly. Like I don't like a billion assembly steps. I think it just like, I find it really tedious, and then like when something doesn't work, you inevitably have to like disassemble everything. But let's get the linear rail out. Apologies if the knife triggers anyone. I can't watch people using a knife. It always makes me feel like really nervous. But knock on wood, I haven't cut myself with a knife in a very long time. So I don't know if that helps. Let's pop this on. We're in. Oh, these do not slide that nicely. So we might have to try something else. That is not going to be this linear rail, because like this isn't going to drop. It's also a little short. All right, new plan, everyone. New plan. This isn't going to be a linear rail. This is going to be, oh my god, how do we do this? This is just a slide I'm putting on the linear rail. It comes, there's like balls inside the linear rail. I don't know if you can see that. And if you're not careful, they'll fall out and go everywhere. Ooh, using a rack and pinion. You know what? I think what we have here is going to work. No, these are just like really crappy. I bought like the cheapest ones, and so they're just a little tight. Like it's fine when you're like, it's completely fine when you're like using like a whatever, like a motor to move this. But we're just gonna use. I have a better idea. We're just gonna redraw it. Top plane, front plane, top plane. Let me get out of iPhone mode. Boom. We're going to use some 8mm rods and some 8mm sliders. And we're actually going to do 2 of them like this and like this. And we'll make them 36 apart because I just like that number. Boom. Horizontal. Yeah, the lubrication will not make the difference there because it's just the tolerances are not good enough. But on these sliders that I use, they're normally pretty good. And we'll do this and this. And I believe I have 200 millimeter rods here. I also have 300. Let's do 300. And we're going to make everything just go off the top mount, which is going to be here. And we'll just print the mount. So coder chit, the ballpoint pen mechanism was actually the original. That was like what got me thinking about this in the first place. And like it probably would work. The interesting thing about mechanical design is it's very much an art. Like very much. There's a million ways to do it. And I think a lot of the time there's no one way that's better than the other way because there really is just like there's trade-offs to everything that you choose. Okay, we're just gonna draw this for now, and we'll maybe how do we want to do this? This is gonna connect to. We're gonna go to here, like. There's some things in SOLIDWORKS that are very tedious, and this is kind of one of them. But we're doing this the quick way. This is going to connect directly to a 20 millimeter extrusion. That's why I'm doing it like that. And we just need to figure out this distance. We're going to go to here. And for now, we're going to make it 12. And then we're going to extrude that as a thin feature on the mid plane. And we're going to make it 2.5. Boom. And that's going to go down to this surface here. Boom. And we're going to make sure that we're doing that. Okay. Sick. WAML, weight activated marble latch. Oh, come on. WAML underscore linear rods. Okay. Wow. You guys have, let me see. Another design, rotating latch. Yeah. Change the container to a cylinder, taper the base, 1/2 inch donut, slice into the 3-1, hold together an elastic band, and spatial latch for your weighted cylinder. Brian, I'm not entirely sure. I understand, but yeah. All right, we're gonna keep going. And you know what? Tomorrow we can make another latch. And you know what? We can spend the whole week designing different latches, and then we can decide which one's the best. How does that sound? Because really, there's no rush. There's no rush here. We're just having fun, doing some engineering. And let's insert component, linear rods. Boom. We're gonna get rid of this. Boom. And now this is gonna move like this. And this we're now gonna change to, let's get rid of this. And we're gonna do this. And I believe they were 36 apart. And this needs to be, I think, 15. And we're designing for, just in case I don't have any of them with me right now. I'll find them in a second. And we're just gonna make this an arbitrary distance. It's like close, but not too close, 8. And we'll do this. And we're gonna make that a thickness of 2.5 so it doesn't break when we push the bearings in. That's a little too close, actually. We're gonna go, maybe we'll do this. Just enough, boom. And I'm being a little bit lazy, but sometimes this is easier than like you'll see what I'm doing. And now we're gonna do this, and this, and this, and this. And I think that they're 24 in length, boom. And that will merge. And then now we're just gonna give like a little fillet here. Make them a little smaller like that, and put one here, and put one here, and there we go. So that's going to slide now on this. Boom. Okay, sick. We wanted to go this way. God damn it. Classic. Classic. Turn around. It's good to be fast. If you're gonna use CAD, like, it's good to be fast. Coder Chit, thank you so much for hanging out. I appreciate it, and I'm glad that you enjoyed. Okay, yeah, we're actually still. This is still gonna work. We just gotta flip this. Boom. So this is gonna slide in here. And honestly, guys, I don't know. So the only thing that I'm thinking about this, like this design, in theory, it's gonna work. In practice, this piece needs to be very rigid so it doesn't like bind up, but I still want to see it through, guys. I still want to see it through. We're gonna see it through. We're just gonna do it. Okay, let's make a part for this to slide here. Thank you, Bearded Printer. I always believe in myself too, for better or for worse. But one thing, we'll just make this a little bit thicker. Ooh. Ooh. You know, I have an idea to make this really, potentially really smooth. We put bearing. No, we're just gonna make it slide and we'll just WD-40 the crap out of it. It's a prototype, guys. It's a prototype. It's a prototype. Okay, let's design this thing that it slides in, which is gonna be on this piece right here. And maybe we'll go on this plane like this. And we're gonna do like this. And do this, make them collinear. Make this, this is gonna screw into this piece because I'm gonna print this piece right here on this surface. And then this piece I'm gonna slide because that won't print nicely and we need this to slide well. So I'm gonna print this, I think like this. It's gonna make sense, but we're gonna screw into it this way. So I'm gonna make this, what are we doing here? 2.5, boom. We're gonna go like this, make this a little thicker so there's some room to screw into it. This is gonna be the distance, and I don't remember what I made, but we'll make it 15 for now. And then this can be whatever, 4. One thing when I'm making my prototypes is like I'm trying not to waste too much filament. Like I don't love the plastic space thing. I actually have a space mouse. I don't like it. I'm very fast with my mouse. I'm very fast with my left hand, not like bouncing between my keyboard shortcuts and my left hand keypad. So yeah, time for me is 4:00 p.m. And this we got to figure out how high to make it, and we might have to adjust everything, but this is just the starting process. And we'll go like this, and then mid-plane that, and kind of like the longer this is, the better, technically. Let's see how long we can make it. We're not going to merge it because we're going to screw it on. And another thing that I actually meant to do before we do anything else is mirror this part. I was going to the top and bottom. We're going to put an extrusion on the back, but I'm not modeling it in right now because I like to flirt with the potential of it not working. Kind of like an idiot. You know what? We actually might be able to use the rods as the top point of the slide. Let me just put this in. And so one thing that like that's really important actually, like when you're designing something like this, is you really do have to think about how you're going to assemble. So many times in the past, I've gotten like halfway through building one of my designs to realize that I completely forgot something like really stupid. But it's just the way it is. So after all this time, I've gotten like a lot better at like kind of understanding the assembly process beforehand. So like in this case, for example, it's like, okay, this needs to go into this, and it needs to be blocked on the front and the back, like kind of like this. So what I would do is I would probably have to, how would we even do this? This might need to screw on after. Yeah, it's exactly when you make it impossible to fit in a piece because of exactly. So yeah, a lot of what I'm doing in the process of designing is also thinking about how I'm going to assemble. And I think what I've decided here is I'm just going to use these rods, which are going to be here anyways, as the front thing. So this isn't going to be able to slide out forward and back. And so we just got to make sure that we get everything set up properly. This is 12. This I have to make, the thickness for that is going to be this. And that is, I think, this 15. So I'm going to make it 12.35. So there's a little bit of clearance, not too much. You don't want it to wiggle too much. There's definitely a balance. Sometimes if it wiggles too much, it just like binds and like it's over at that point. Okay. Then the thickness of this piece right here is going to be the thickness of between here and here minus a little bit. Let's just go back to this and get that right first. This is going to go right up to these. Should we make it like kind of like latch in? That'd be nice. I mean, it might not be necessary, but I'm going to do it. Because like, why not? Just because it looks nice. So if we do this, this has to be like 8.5. So now it's going to do that. But then we go on this here, and then we do this. And this, and we're going to make that like 8.15. And these are just like tolerances that I'm baking in based on experience. But basically, I just want to make sure that like if I'm latching this in, it's not going to be interfered with by like, see like this. So this part, and you know, we might as well do the screw in components here just while we're at it. The drop is going to be like, it's arbitrary. Basically, I can make these rods however long I want. And I'm going to use these two components to make sure that they're like parallel. You do run into not parallel situation, but I think that this will be fine. We're going to make this a little thicker, I think. Let's just do that now too. So it's going to be rigid, and that should make it parallel. These should be good, pretty good. They should be pretty good. Okay, and where did this go? This went here. So let's make some screw holes for that. And I'll just make them like here. And I kind of bounce around with the hardware that I use, but for the most part, I really like to use these number 4. I don't know if you can focus. Okay, I'll show you on this camera here. These number 4 screws, which have these like kind of thick, they're like thread forming plastic screws. So on a 2.75 millimeter hole, which always ends up being smaller because of the way things print, it ends up being perfect. And then I'll show you the clearance hole for that after. But for now, when I design, I always try to design the non-clearance hole, because you can always drill a hole out, but you can't make a hole smaller very easily. And I'll show you what I mean by that. So this is going to be 2.75, and these two are going to be equal, and we're going to make them like here and here. That looks pretty good. Yeah, I'm going to leave all these live streams up. I'm never going to take them down, and I just want to make good content for you guys. Also get to hang out with you guys and like just get a chance to know you better, because you know it's different when I'm like just like working on my own and like I'm here by myself, and then I post a video and like the only people I hear from are the people who are just like trolling me. Okay, boom, concentric, and let's just mirror that. Boom. Oh, you know what the problem with this is though? Oh, we'll fix it. And we're just gonna make it blind, and we're gonna make it 2.5. I don't play wiffle ball, guys. I don't even know what wiffle ball is, honestly. Boom. Okay, so that's good there, but we're gonna make this a little bit higher. 3.5. I'll make it a little bit bigger. Boom. And now we got this, and then this we're just going to draw holes off of those holes like that and like that. And those will cut in, I think I made these walls 7, so we'll cut in 6. Okay, oops. What did I do? Oh, I made a boss, that's why. Make that a cut. There we go. And then, so here's what I mean. So right now they're the same size. And so if I forgot to change this, I would just drill them out. But I didn't forget. And so I'm just going to move the face on these holes. And they're going to be clearance holes. And 0.35, other way. And now we got a clearance hole. So I'm going to screw through this into this, and then it's going to be one part. Can I design this with the good old pen and paper? I mean, if you've been here, you've seen my sketching. So technically, yes, I could. But at some point, it's always just better to drop into CAD and get it done that way. Okay, let's see how, you know, actually we're gonna do this. We're gonna set this dimension in the sketch by not having this dimension. We're gonna go from here to here. 7.5, looks good. So that means that this needs to be 7.5 thick minus some clearance. So we're gonna make it 7.25, boom. Okay, nice. So that's actually set, and I like the way that looks. I think that's gonna work. Okay, so now we gotta figure out this latch and get it kind of dialed in. So it doesn't need to move that much, but we want it enough that like it's kind of held up on this end nicely. And it's also got to be clear of these. So I think what we need to do is actually change the dimension of this. And we're about to break everything, but don't worry, we're going to fix it when we do change the dimension of this, 25. That at least just gives us a little bit more clearance. And hopefully having these like tighter together is going to make it a little bit smoother as well. Okay, cool. And then this needs to come in the other way. So get rid of that. This goes here. And that goes there. And then there, boom. And let's just make sure that needs to stick out quite a bit more. Let's just do a quick edit on this part. So that's there, but we actually need that to be sticking out like this. What do you guys think about this time for a stream, by the way? Like who here, where are you guys all located? Where's everyone? Give me some like locations down here. Just so I know what's the best time of day to be doing this. It's always gonna be sometime in the middle of the day. Because I'm at work during the day here. Like I'm here in the shop. Vacation, nice. Ohio, British Columbia, Norway, France. Okay, so for the Europeans, it's the evening. Tuning in from work. Okay, that's good to know. I feel like this is like a pretty like work safe live stream. Like if you're working an engineering job, you can like, you know, you're like kind of like working. From India. I feel like it's late in India right now. Isn't it like middle of the night there right now? Okay. So we got Cape Town. Wow. Cape Town Oh, 22:12 in Cape Town. Oh, but it must be tomorrow in Cape Town right now, right? It's like Tuesday in Cape Town. So, okay, just so we're like clear here. The thing that I think might be our downfall with this whole plan here is potentially this latch design. But I can almost guarantee that I'm going to have a better way to do it tomorrow. But for now, while we're just like trying to do like stream think, this is going to have to work. It's going to have to work. Okay, this is going to sit here at its topmost point. It's clear there. It's clear there. And this has to just be a little bit longer, it looks like. Okay. That's going to sit on there. Save. And then now we got to get this part set up. And these don't need to be nearly as thick as they are, I guess. That one looks fine, but this one doesn't. This is just the trigger side here. So we'll make it smaller. Like we'll make it like 7. And I want that to stick out more. Like 30. You know, I always use 36 as a starting point. It doesn't always mean it's the right one, but for this one, it is the right. And then that's going to move that much. So we got to make this a little bit longer. So this is right now in this position, right here. This is the latched position. And then, so this has to be sitting outside of this cup at the bottom here. So we're going to go like this, 25. And basically there's going to be a spring pulling this way. But it won't be able to move that way because this thing is going to be in the way. Sorry, I'm thinking too much. How many hours? Guys, I sleep like lately like 10 hours a night. It's crazy. I've been so tired lately. I don't know why. I've also been like sick quite a bit lately, so maybe that's why. I've just been trying to fight off that. 16 maybe, boom. Okay, that's good. That's gonna sit there. Let's just adjust this to its top position. Like we'll call this like there or whatever. And then this, just for the sake of, it has to get to here before the latch pops in like this. Boom. Yo, I actually think as long as this doesn't flex too much, this whole system's actually going to work. Here's where it could get screwed up, is what I'm thinking, is it could get screwed up in the amount of weight required to push this down. If this weight is too high, it might put a little too much weight on this latch, and so it won't slide, but we're gonna figure that out. We're not gonna do any differential equations here because we're vibing. This is vibe engineering. So now we need sometimes I do edit in context. We need a slot on the side of this for the latch to be able to slide out. And we're gonna make it 8. And we're going to make this centered. Boom. And this is where it has to come down to. And look at that, 36. Perfect. And that's going to cut through to the surface here. Boom. Let's see if it's starting to make sense here. We just got to adjust this a little bit. 35.5. Perfect. Okay. So this is actually starting to make sense. This is going to be sitting up here. Marbles are going to drop into it. It's going to slowly drop down until the right amount of marbles are in it that it's going to do like this. Then that's going to allow this to pop like this because there's going to be a spring pulling this way. And I don't know exactly how we're going to do that, but we're going to figure that out still. And Bearded printer, the spring just can't be so strong holding the latch against the box. Okay, so here's the thing. I think you're understanding exactly right. If this spring that's pushing this way is too strong, but the thing is we're working on different forces here that I think like you would have to have a really strong spring to push so hard against this that this thing won't be able to drop, I think. Especially because we're adding weight to this, adding weight to this, adding weight to this, that it should be able to drop. But because we're working on two different axes on these, it's just the friction force of this that we have to overcome. Yeah. I think that we're going to be okay. And if not, we're going to adjust. But I think for now, I actually do feel pretty good about this. The only other thing, this is the thing, is once we're here and it, oh no, I was thinking maybe it'd be hard to adjust. Okay, so the friction force technically is easy to calculate, but there are so many factors here that are really hard to calculate that to me, it's almost not worth it. To me, I could do the free body diagrams, calculate the forces, but it's all so theoretical that there's at some point, we're gonna have to build this to test our theories anyways. You might as well just build it and then we can vibe from there. It's kind of my thought process, and it's kind of the way that I always work. So we use a bit of our knowledge of forces and our intuition combined with our intuition of physics, and that's going to allow us to create something that works. So for me, my intuition is telling me that this is going to work as long as this piece is strong enough and doesn't flex too much that it causes, basically what would happen is this would flex down and out. But yeah, bearded printer, literally that's exactly it. Honestly, a lot of the times I build something being my whole, this isn't gonna work. And then I literally just put WD-40 on it. It's like king of the hill, WD-40 and it works. So I think that it's worth exploring this. We're actually kind of ready to print this. What else do we need here? What else do we need? I'm just trying to see if there's anything I missed here for the printing. I think we're probably good. This might be embedded metal marbles at the contact area. That's an interesting approach, definitely. I think change the material to adjust the friction. One thing that I've actually found is PLA on PLA is quite low friction. And then PLA on PLA with WD-40 is extremely low friction. So, but yeah, ForgeCore is actually very correct on this. If this piece is causing too much of a problem, we put a little bearing in here and it will just roll off. And that would solve that problem. I don't think that we honestly have to worry about that right now. Claude can do a lot of things, but I don't know if it can figure out how to do this. So the best way still to do this is just build it and then try it out. But okay, let's just do one last check here to see if we are ready to go. One thing that I need is a way to attach a spring on this end. And what I'm thinking I want to do is I'm just going to put some holes in the bottom of this. And we're just going to attach a screw and an elastic band. And a lot of the time when I'm doing designs like this, where I'm not entirely sure how much force I need to, I'm just going to make a lot of holes. And that allows us to adjust very easily. So I'll go 1 hole, 2 holes, 3 holes, 4 holes, 5 holes, 6 holes. And 5. And we're going to make all of these equal, and we're going to make all of these 2.75. So we can just drop a thing in. The spacing is going to be 7.5 there, and we're just going to center it on this just by the way, like what I'm doing right now, where I'm using all these like equal constraints, it just makes life easy. That way I can just adjust this really easily and it just changes the spacing and like, yeah, it's perfect. Okay. We're gonna make that cut in there and I wanna go all the way because I don't wanna mess with the friction of this. So that looks good. That looks good. There was something else I was thinking, but I can't remember. Oh yeah, I forgot that this was supposed to be attached to an aluminum extrusion. So maybe we'll just extend this out a little bit. Like that. And, oh, that's actually not gonna work either because then it's gonna get in the way of these screws. So we'll extend it out a lot more than I thought. Then we should be good. We're gonna extrude that. Oh, didn't finish the sketch. Boom. Extrude that down to here. And merge it with this. Boom. And that means that we actually what's your deal? Oh, man, this guy. It's because I constrained it. This is one thing that I find a little bit annoying about SolidWorks, I gotta say, is because I did this, it constrained it to this, and because of that, I can't just move this mirror down like that. But we're fine. It's fine. It's fine. Now we just got to adjust this sketch to be there. It's like the only thing, like sometimes SolidWorks, that like frustrates me a little bit, but it's all right. We figured it out. And actually one other thing that we got to do before we do that is we're going to make a hole here so we can attach it to the extrusion. 5.5 cut through all. And then another one for the screw head canter bore. And that I normally make 10.5. Boom, cut. Offset from this surface 5. 5. Boom. Okay, so now we got our screw. There we go. It's perfect. Boom. Got that. That's ready to go. On this thing, we need to put a hole here. Oh, I actually wanted to make this wall thicker, but I'm just going to move the face because I'm kind of lazy. That looks good. Maybe we'll go even more. Boom. Okay, sick. What is my GPA in my engineering degree? It depends on it depends on when we're talking, you know, like at one point in time, before I actually got serious, my GPA was really bad. And then after I got serious, my GPA got good. How do I determine the right dimensions of the project I'm modeling on the fly? So this is just like a combination of a few things. I've just built so many things now that I kind of have like a library in my head of dimensions that I use. And a lot of those dimensions, like thicknesses of walls, and I said we were going to talk about that. Now we actually can. Like, let's look at this. So, oops. So I made the thickness of the wall here 1.6. Very specific dimension. And the reason for it is when I save this as an STL, and I still use STLs, honestly, because I find importing like step files into slicers is annoying. And I also have a macro that would save that quickly, but I had to make the folder. But let's open Bamboo Studio, and we can import the part, cut it, and you'll see where a lot of my dimensions choices come from. If it ever loads. Okay, there you go. There I go. And we'll update that later. Cancel, prepare. And let me just resize the window so it fits There. Okay, so when we bring that part that we just made in, and we slice it with my normal 4mm nozzle settings, if you look here, 1.6 millimeter thickness gets you 4 walls. Just like beautiful, clean walls. If we made this wall like 2, which is kind of like a bad dimension for 0.4 millimeter nozzles, oops, and we'll save it. And we bring that part in, and I'll just bring it in next to that. Boom. So you get an extra layer line in there, which, I mean, you know what's funny actually? I have some like old rules because like the slicers used to be worse. That this used to be like a kind of like crappy infill, but they've definitely improved on that. So you know what? I'm taking it back, but definitely like if that was 1.2, let's see what that gets us. I think that gets us 3 lines for thickness, and that honestly might be fine too. But this is one of the reasons. This is one of the things that determines some of my choices and dimensions is, okay, so that gets you 3 layer lines. And those are nice. Like it used to not put this like clean layer on the inside. Honestly, 3 layer lines is probably enough for this. So I'm gonna switch that to 1.2 and leave it because we're making a prototype here and I don't wanna waste a lot of plastic. And I want this to print fast. And so that's gonna be pretty good. Although on this one, I think we're gonna leave it at, what did I make it? 1.6. I'm gonna leave that at 1.6 because I want that to be, this is just gonna be a little too flexible and kind of gross. Okay, so I think this part's ready. This is the thing that just falls down. So just gotta think through the design. So this, I'm gonna slide in from the top, put the screws in, put the elastics on. So that's good. This, I'm gonna pop the linear sliders into there, pop them onto this, then I'm gonna push this on. So that looks good. So, okay, so it's always a multiple of the line width and layer height, but it's actually not, which is what's interesting because you can make thicker and thinner parts. Yeah. Okay, sorry. What do you mean by do I do the thought on my engineering degree? Currently, what I'm doing on YouTube, do this. I do XE10. Can you expand on that a little bit, please? But okay, I think that this looks pretty good. I think I've decided that we're just going to use supports to print this part. That's the other thing. So we're going to slide this into this, wrap it around here, then we're going to screw it into there. That looks fine. That looks fine. Guys, I think that we're ready to print this. Let's do it. I just want to strengthen this piece here a little bit before we mirrored it. And put some fillets there, like that. That looks pretty good. And I want to put some fillets, I think, here as well. That's a chamfer. We want fillets. May not be necessary, honestly, but we're doing it anyways for style. And we'll get that one as well. No, we won't. We won't get that one as well. Okay. And then on this one, we actually don't need these tabs, and I'm going to be really lazy here. Because I honestly should have, I'm just going to cut them off. Like, this is kind of like ugly CAD, but we're just doing it because it works. It works, and what's gonna happen is someone's gonna like look through my feature tree one day, if ever, and they're gonna look at that and they're gonna be like, "Why did you do it this way?" And the answer is because I was too lazy to make a separate hole or mirror the hole, and so that's why. Okay, I think that this looks good, and let's print it, and then that way tomorrow we can test it out, and then we can design another latch too, with a different concept. If the moon was a rack of ribs, I would not eat it. Okay, that's my answer. Okay, so this looks good. Let's save this as an STL. And we need this as an STL here. Am I missing something there? Oh no, no, we're good. We're good. We're good. I was just worried for a second there that like this elastic would be interfered with, but I think we're fine. It might get squeezed. Oh, guys, we missed something. Look at this. This is what we missed right here. If this were here in this position and it were to drop, it would get stuck right there. Now, what do we do about that? What do we do about that? This is what we do. This is kind of a terrible fix, but I like it because it's kind of satisfying too. We're going to do this and this and this. This is actually not a good fix because of the way it prints, but guys, I don't have the DNA of Albert Einstein. I have the DNA of someone who's just made so many things that I catch this stuff now before I print it, not after, because I used to catch this stuff after I print it. I've made so many things that I have figured out how many times things that go wrong that in simple designs like this, I can get them pretty much on the first try. But that's because I've gotten it wrong so many times. So what's the solution here? The solution here is to make this a little bit longer so when it pops off the end here, it doesn't get in the way. And it's the same thing with this right here. The solution here is to make this one we don't have to worry about, but we have to figure out how to make this longer. So yes, the answer is experience, always. Okay, that's better there. So that won't interfere now because that's going to sit right there. Yeah, it doesn't interfere, but then when it pops off like this, now it can slide without anything getting in the way. Boom. Okay, that's good. It depends. I think I used to be very, like when I'm talking about the fix this lazily thing, I used to be very intense about like doing really clean CAD. And now I just, like in a situation like what I just did, like I'll fix it lazily, and if it messes me up in the future, then I'll do a cleaner fix on it. But for the sake of just being fast and not bogging myself down in tasks, I like to fix it quickly. I would love to do this today, but I feel like this is gonna be printing for like a half hour, and like I don't know what we're gonna do sitting here for a half hour. So I think what I'll do is I'll save it for tomorrow. And for anyone who's like has to check out of this live stream or might miss it tomorrow, I'm going to build this tomorrow on stream. My desk is always this dirty. If you want it, my shop is always this dirty. But yeah, how many marbles is it gonna fit? I have no idea. And we're kind of like we're kind of just vibing right now, and we're gonna like that's like these quick prototypes. So what have we been here for? Like how long have we been streaming for? Does anyone know? It's been like what, like 2 hours? Let's see. Yeah, I'm gonna keep the live stream available to view after, so don't worry about that. But yeah, 2 hours. We have a quick prototype. So tomorrow we're gonna test it, and we're gonna learn a lot more than I could have learned thinking about this for a lot longer. So. Yeah, my educational background is in mechanical engineering. I went to school for mechanical engineering, but a lot of my experience comes from just building stuff. Prash, what's up, man? You know what? That's so funny you say that because I forgot that you were one of the OGs in those live streams. Yeah, I decided that we're going to do a little bit of live design again because it's fun. Okay. Let's just solve this last problem here, which we realized really, like, so this is gonna sit here, and then when it triggers this way and allows this thing to drop, it's gonna get stuck here, and then it's just gonna jam. So we basically have two options. Because we're printing this part, I'm printing this part, this is gonna be on the surface of the printer. If I cut out here, never mind. Change my mind. We're gonna do that, and we're just gonna make it work. We're gonna do this, make this, and like this, and we're gonna have this overhang like that, and then we're gonna thicken it on the other side, and it's a little bit of a, you know what? I don't even know if I want to call this a lazy fix because it's gonna work well, and I like that. So we're just gonna do it. We're gonna be happy with it. What am I making, Prash? Does someone want to fill Prash in on what I'm making? By the way, Prash is coming to town. Prash, I'm excited to see you, man. Prash is coming to town, everyone. Prash might even be part of the live stream on Thursday if we're doing a live stream still by then. I don't know. We'll have to see. If you guys want me to keep doing this, let me know. If you guys are enjoying this, let me know. Oh, God damn it. God damn it. So this is another thing that I just always make a mistake on in SolidWorks is, so I just made a assembly level feature here. So the cut worked, but this is an assembly level feature, and I don't like that. So I'm going to delete that. I'm going to copy this. I'm going to paste it on here. And I want to make this a part level feature. So I can't remember what that was, but now we do that through all. Okay, now we're good. And that's good. Everything looks good here. And now we can delete this. Keep doing lives, says Kobe. We got to get Kobe on the live stream one time, eh? Kobe is Forge Core. If you guys don't know Forge Core, go check it out. If you guys don't know Prash Makes, go check out Prash Makes as well. Parallel. This is just for fun. This can look however we want, but I'm making this look like this because I've decided that's how I want it. I just want to reinforce it so it doesn't flex too much. And this is one of those things, I don't know if it matters, but it doesn't hurt me to do this. And so we might as well just do it. Boom. And we're going to go up to this surface. Boom. This part's now done. Oops. This part's now, oh, come on. Hit the wrong button. Boom. Okay, sick. So when that prints like this, we only need supports here and here. We actually don't even really need supports on this one. I don't think. Let's just add in a chamfer here because that's going to print this way, and that should just get out of the way. As long as it doesn't mess with this. Just make it stick out a little bit more. Like that. Okay, so that should be good there. And then what else? Maybe we're going to add a fillet here for a little bit of rigidity. And that shouldn't mess with anything. Right? Yeah. Okay, let's put this back here. So let's just double check everything before we go. So this is going to sit on here, and there's going to be an elastic band that's pulling this latch this way. But it's not going to be able to move because it's going to be sitting against this right here. Okay, so that's going to be sitting right there. What's going to happen is this is going to start filling up with marbles, and the elastics are going to stretch until it gets to this point right here, at which point it's going to pop off. And I guess, yeah, I don't know. It's fine for now. It's going to pop off, causing this to go this way until it gets to basically this point right here, I guess, until it hits this. I think I want to put a blocker on that, which we can do that easily. But it's going to pop here, and then that's going to allow this whole thing to drop down. And like, let's look at it from all angles and make sure we're not missing anything. And oops, we're trying to go from the top angle now. Yeah, that's going to drop. Maybe we'll make this a little bit, stick out a little bit more even. There we go. And then that should drop all the way down. And this is actually all just going to be connected. So this is going to be dropping together like this. Okay, it looks good. I generally try to, like, I design for print from the get-go. But like that's kind of like, you know, I've just done this so many times that like I just kind of know how things will go from now on. And like sometimes, you know, so like that's why, like when I was designing this, like I would have probably made the hole first, but then I was like, you know what, I'm printing it this way. That's gonna be an overhang, so I might as well put that in. The reason I'm not making this an overhang is because we need it to stick out like that. So we're just gonna put supports on that, and it's not gonna be a big deal. It's gonna cost us like 2 cents in plastic. But I think otherwise this is ready to go. So let's print it. All right, I think we're gonna call that a stream for today. Before we go, you know, I'm just gonna crack a Diet Coke, Diet Pepsi. And like we can just chat for a bit while we finish this off. So if you guys have any questions, I'm done for today on the design. So yeah, let me know if you have any questions or anything that you want to know more about. I'm here for all of it. It's nice. This is really fun, guys. I'm happy that you guys are here for this. The John Travolta of 3D printing. I've actually heard that before, many times actually. You should see my brother. My brother looks like John Travolta, actually. Should make the tubes that go around the rods longer. This way the torque can't bind the mechanism. The tubes that go around the rods. So these tubes here that go around the rods are going to be, you know what, let me show you what it is that I'm working with. I think that they're in, oh my God, they're here. And then, okay, so these are the shafts. Let me swap to a different view here so you can see better. Boom. So these are the shafts here that I'm going to be using. And these are the linear sliders, and they don't bind at all. Like I'm putting a ton of twisting force on these, no binding. And they're like with a little bit of weight on them, they like slide really nicely. So I'm not concerned because I think the weight of all of it is actually going to be like really good. Even with like a lot of force, you know, sometimes they actually tend to like, yeah. So we're not going to print these tubes. We're going to be using these steel rods. These steel rods are going to go, let me make this smaller so you can see. So these linear sliders are going to be going into these holes on this piece right here. And they're going to be, I'm going to be jamming them into these holes here. So let me show them again in the parts. And so that way I know that this is going to slide really nicely. These linear literally every mechanical component that I use, I get from Amazon. Pretty much. It's rare that I'll go to McMaster-Carr because it costs a lot for them to ship here. I mean, it's really great, and they also ship next day. But yeah, I didn't make any assembly level modifications. Fortunately, I did by accident, and so I switched it. But everything is in the part level. I don't like making assembly level stuff. Kind of scares me a little bit. Yeah, any other questions out there? Anyone else got any questions about this design? Okay, let's actually take a poll here. What do you think the chances are of this succeeding? Is my question for you. I'm gonna give it I have like a 90% confidence rate on this. Ooh, on the first print 40. Okay, that's lower than my 90%, but I do have the 75% is probably it. Prash with 100%. I appreciate that. Anyone who's saying 100%. I mean, it's good to have a healthy amount of at least 10%. Oh, dude, there's no hate on that. Like, these things can definitely fail quickly. Yeah. Any projects that I'm excited that I can tell you about? Honestly, right now I don't have any projects coming up that I'm like 100% sure that I want to go after. What if Elon Musk would buy my workshop? That is an interesting question. I'd be down to chat. I'd have some questions for him for sure. For sure. Appreciate your brother. Mad respect. Have I worked in the industry? Yeah, I worked one time for like about a year at a golf company, like designing golf clubs. And I worked in the toy industry for a couple years, designing toys. What's my first question to Elon? The first question to Elon would be, why the Cybertruck? Honestly, I'm like so curious about that decision-making process. Maybe that's a. I mean, there's a lot of questions for Elon. I don't know. That's right off the top of my head. I haven't thought about this before, Prash. Putting me on the spot here. What computer do I have? I'll just show you. That's why we got this mobile camera, which is kind of sick. So this is my computer. That's the inside of the computer. You can't really see it. There's the inside of the computer. Honestly, it's just like a random, it's a custom build. There's like a store here in Toronto that did the build for me. I believe it's a and it's like, I can't remember right now what Dell's, not Dell, Intel's. It's a 7. So I sound like an old man. It's a 7. Yeah, I live in Toronto. It's a God, I can't think anymore. Oh my God. It's a NVIDIA workstation graphics card. You know, why don't we just do this? Just go computer. How do we get it? What's it called? What's it called when we're looking for? Oh, system information. There it is. There you go. Okay. So we are running a. Hopefully there's no information here that you guys shouldn't. One day I'm going to dox myself. Okay, it's an i7. It's pretty fast. 3400 megahertz. My graphics card is, where is it? Graphics, components. Where is graphics? I don't know. It's a Quadro 4000, I think, or something like that. So yeah. Why don't I use a normal mouse? Because my shoulder hurts after a while. And also this mouse. So when I'm doing CAD, I got this map to 4 different buttons. So like, that's escape. Oh, that's actually delete. Sorry, it's like built into my muscle memory. But I don't. But so I have like delete. So if I want to delete something, it's just one quick motion. I have escape. I have like this button, which is command, and then I have this one, which is S for sketch. But I don't use it actually very often. And then the most important one is this button here is enter. And just like this is an ergo mouse, so it doesn't hurt my shoulder. One day I'll have a get together, like a meetup in Toronto, and you can come to my house. But it's not my house; it's my workshop. But yeah. Okay. Is there a date for the next video about sorting system in my workshop? So the sorting system in my workshop, the video flopped. Like, it just didn't do well for the amount of work and money and time that I put into it. And also I'm kind of bored of it because like I want to make mechanical fun like projects, and that's like this project that like is just so functional and kind of boring. So right now it's on hold. Yeah. Sorry. You know, some people really loved it, but like I don't know. You know, like for me, I just like I'm kind of bored of it, and like yeah. I have a space mouse. I have this one from 3D Connection, but I don't use it because I'll show you how my hands are set up on my keyboard here. So like I have this is always set up here, and all my shortcuts are here. So like between these, between this and this, having like a space mouse as well, when I already have my hand on a mouse that I can manipulate and like move around really easily, like I find that I'm way faster with this than I am with the space mouse. So that's the reason I don't use it. People have said that I would get used to it, but maybe I will, maybe I won't, I don't know. My next short will probably be this latch, honestly. Why not? And that's what I think could be potentially like really cool about these live streams is like you guys are going to be here for the live stream, and then when I drop the short, you guys are going to be like, I was there. Like we were part of, we made this together. And so I think that's kind of fun. Have I ever explored perpetual motion? No, I have not. Because I learned a very long time ago that it's physically impossible. Although some people may argue with that. But yeah. I appreciate it. I mean, the video flopped from a performance standpoint. The main reason why I'm not doing like long form videos right now is because, so I mentioned before, I have ADHD. Long projects take me a long time, and I get lost in like the whole process along the way. So like when I spend 2 months on a project and then the video doesn't like perform the way that I need it to, like sponsors look at that and they're like, oh, like the video didn't perform. We're going to pay you like not enough money for the next video. And then it's like really hard for me to sustain making these projects. So with short form, I can like move fast. Like this project that we just worked on together, I can make a short about this, and it's going to be cool and visually very interesting. I think like it's going to be a good short. Like I like how this is going. I like where it's going to land. So as a result, we can move fast, and that's super fun. It's fun for me, and and I can basically just like throw down side projects on side projects on side projects. So yeah, that's kind of why we're working on these like fun, quick projects, and then this ultimately can like eventually, like this will eventually become part of a bigger project. Maybe we'll make a long form about that. So we'll see. Yeah. I don't want to get too deep into the business side of being a content creator, but yes, basically like sponsors look at how many views you got, and then they try to get a deal when your videos haven't performed well. So my last couple long forms haven't done what they need to do in order to like that project, the sorting robot, like that was like, I kind of was like, you know what, guys, we're just gonna like go full out on this. We're gonna spend the money and buy the things that we need to buy, and we're not gonna like worry too much about it. And ultimately, it ended up like being a great project. Like it's cool, but for me, the sacrifice that I make in being able to design and build anything I want is it has to work on social media. Like I have to make the videos about it, and it has to work, right? And so, yeah, that's kind of like the hard part about it. And so when a video doesn't perform well, and a sponsor looks at it and says, you didn't perform well, like we're gonna try to get less money for you. And I'm like, but I want to keep like spending money on these projects and like doing, there's like this cycle that doesn't work. I don't know if that makes sense to you guys, but that's about as far as we're gonna, it has to be packageable. Exactly. Super valid designs. And that's just like life in general, right? That's just business in general. Okay, resin printers. I like resin printers. I hate the process. So I have a Formlabs machine, like having to like put on gloves to like touch the thing. And, you know, I always end up with like resin on my like wrists and arms, and I don't know. It just like, it's just like, and I don't know. Just like it's like chemicals and smells, and that doesn't happen with FDM printing PLA or PETG. And so I really like that. And so as a result, I design specifically for it. And generally speaking, like 95% of the time, it seems to work. Okay, let's go through this ADHD. How do I actually finish projects? When I quit my job as a toy engineer to be like a at the time to be like a kinetic sculpture designer, which kind of morphed into being like a fun engineering project thing. Basically, I said to myself that I have to finish the projects that I start. And there's like a little bit of like a, there's a little bit of like a formula there, but a lot of the time I'm not going to start a project that I'm not planning to finish. And that's just like the part of me that has to like fight through, like my ADHD, like have to fight through that and not get too distracted. And like if you watch it in my videos, there's always side quests, or there's always like shorts in the middle of these long projects that are side quests. And that's how I like let my ADHD just like, go nuts in the process. But I always try to bring it back to, I have to make sure that I finish the project. Right now, I'm taking a break from these long projects because, I like building a latch like this. Like this, we built this in 2 hours. Tomorrow, we're gonna have this in the hand and know if it's working, and then we can keep building off of that, which is fun. And I think that's like, I don't know, it's cool. Okay, next. How did I film the clip of my latest? I have a drone, so I use the drone, which I actually just got before that video. I actually got to use it a couple times in that video, which was fun. Let's see. I want to make sure I didn't miss any of you guys' questions here. Would I ever consider making a SolidWorks 3D printing kinetic sculpture tutorial? Maybe, but I think that like to me, like making a tutorial is just like it's gonna kill my soul, like from the ADHD, that whole thing. So I think what I'm gonna try to do is just like fill these live streams. If people keep coming back to them, if it keeps working, I'm gonna try to fill these live streams with all this knowledge. And hopefully just by watching, you can like gain a lot of stuff through it. Yeah, and that goes to EDU, EXE10. Like if we just keep doing these streams, I don't know. What time do we start the stream at? 2? Maybe we'll stick to this time. I think it's a good time for me to do the streams. I think like 2 to 4, 2 to 5 in the afternoon. I'm gonna do my best to not come in here tomorrow and assemble this thing, but maybe I will, and then we'll look at it on stream tomorrow and then decide what to do next. But I don't know. This is all new, so I'm gonna try to see if we can figure out like the best way to do this moving forward, and we'll figure it out from there. Yeah. All right, guys. I think we're gonna call it because I'm starving. I need to go eat something. But yeah. Hopefully I'll see you again the next time we do this. I don't know. I don't know. We're going to figure it out as we go. But I really appreciate you guys all hanging out. And yeah, we'll chat soon. Peace out.